Hello everyone, today we continue our bow and arrow tutorial part 5. Now if we aim the bow and look at the character from the top view, then when she walks right, the arrow will point to the wrong direction because of the rotation of the right hand is different from the left hand. Go to our arrow blueprint, open the arrow and at begin play, get player character, cast it to third person character, then get child actor, then promote to variable, name it bow, get our bow, then get world location of the bow, break the vector and make vector. For z value, add it to value, connect x to x, y to y, and subtract it, get our static mesh, that is our arrow, then get world location. Take the world location of the bow and subtract with the location of the arrow. Normalize it, then call make rotation from x. Get our static mesh, set world rotation, set our x rotation to our new rotation, and connect event tick to this node. Now our arrow points to the right direction of the bow. Let's work with the camera. Go to third person director, go to camera zoom, and add a new timeline. Click on the timeline, set the length to 0.25, compile it, and add float track. Right mouse, add key to curve float 1. Set the time to 0 and value is 0, and add new key, set time to 0.25 and value is 1. On camera zoom, connect it to play from start, and camera unzoom, connect it to reverse. Get camera boom and set socket offset. Split track pin of the socket offset, get our new track, multiply it with 100, connect it to socket offset X, multiply it with 75 and connect it to socket offset Y, multiply it with 25 and connect it to socket offset Z, connect update to Z socket offset. Compile it. Go to begin play, go to begin play event, then get player camera manager, set view pitch min and set view pitch max. Set view pitch min to -70 and set view pitch max to 70. Copy our pitch adjustment and go to aim bow event. And when we play the standing draw aim animation montage, pass our pitch adjustment, connect it to set view pitch min. Set pitch view pitch min to -45 and set view pitch max for 35. Then go to release right event, pass our pitch adjustment and connect it to aimable. We set the minimum and the maximum of the pitch camera manager because we want the player not able to view directly from the top of the character. Now it's working, and when we release our right mouse, the camera will unzoom it. Next, we will make our character able to aim the bow down and aim the bow up. Go to Blueprint Interface Animation Blueprint. Go to Set Aim function, add new input, name it Recoil. Add new function, name it Set Upper Body Rotation, and add new variable, rename it to Upper Rotation. Select variable to rotator. Go to Animation Blueprint menu, click on Anim Graph. Create Transform Modify Bone. After our control rig, connect it and connect it with Output Post. Add new variable, name it Current Rotation Alpha. Select variable type to float. Get current rotation alpha, make it to alpha, and add new variable, name it upper rotation. Select variable type to rotator. Get upper rotation Connect it to rotation. Click on Transform Modify Bone. Add rotation mode. Select Add to Existing. And rotation space, set it to component space. Select the bone to modify. Choose Spine tool. Go to Event Graph. Get Event Set Upper Body Rotation. And set the upper rotation to our upper rotation variable. Go to Event Set Aim and create a branch from our aim. Create new variable, name it rotation alpha. Select variable type to float. If aim is true, set rotation alpha to 1. For recoil, create a branch, and if recoil is true, set rotation alpha to 0. Go to our update animation sequence, add a new pin, get current rotation alpha, and get rotation alpha. Create a loop function. Loop between current rotation alpha and rotation alpha. Set alpha to 0.08 and set current rotation alpha from the loop value. Connect it with the sequence. Go to Third Person Character Blueprint. Then go to Event Tick. Get Control Rotation. Right mouse and split Struct Pin for the return value. Get Mesh. Get Anim Instant. And call Set Upper Body Rotation Message. Click Struct the upper rotation. Then call Subtract. Connect Pick to the Subtract node. Set W to 360 to subtract the pitch. Connect this value to upper rotation row. Go to Release Write Event, and before the time to release timeline, we get Mesh, get Anim Instant, then call Set Aim Message from the Blueprint interface. Set the recoil to true. Let test play it. Click right mouse and aim. Now we are about to aim down and aim up. Go back to our third person character. Then go to Input Action left mouse. We will make the character play the recoil animation after we click the left mouse to shoot the arrow. Then get Mesh, call Play Montage, connect it, and go to Animation, Standing Aim Recoil Animation, right mouse, and create Animation Montage. Apply this animation montage to montage to play. Call Aim Bow Event to make the camera unzoom. Then get Mesh, get Anim Instant, call Set Aim. After we complete, we call Set Aim function and set recoil to true. We set recoil to true to make sure that when the character is aimed down, then she play the aim recoil animation, the character still aiming downward. And after the animation is complete, she about to aim forward back. Go to Third Person Character Blueprint. Then create a custom event. Name it Arrow Curve Project. Then add a spline. Name it Arrow Curve. For custom event Arrow Curve Project, add new input. Name it Arrow Curve. Then set Arrow Curve to Arrow Curve variable. Create a branch. Call Predict Projectile Path by Trace Channel. Get Child Actor. Get World Location. Get Up Vector. Multiply it by 2. Convert Pin to Float Single Precision and set it to 2. Get our world location. add with the out vector. Then set it to start position. Get follow camera. Get world location. Split struct pin. Call get forward vector. Split struct pin of the rotation. Get child actor. Get world rotation. Use only yaw. Add it with 90. Then connect it to yaw of forward vector. For y value, add it with 5. Connect it to pitch. And x connect it to roll. Normalize this vector. Normalize it to create the unit vector. Then multiply it. Create a new variable. Name it string. This is the string that our arrow will shoot. Select variable type to float. Compile it and set our string to 6000. Convert vector to float. Connect our string to it. Connect this vector to line velocity. Then get save. Make array. Connect it to actor to ignore. If our arrow curve is true, we will predict the path. Then get spline. Get number of spline points. Subtract it with 2. For out path position, create a for each loop of that. Create add spline point at index. Array element add it to position and array index connect it to index. When it complete, call for loop. Connect the index to last index and loop body. Add spline mesh component. Make a transform. Connect return value to relative transform. Click on manual attachment. Click on add spline mesh component. Then choose our static mesh. Go to our cube. Then apply it to static mesh. Promote the return value to variable. Rename it to spline meshes. Then delete the spline meshes. Make our spline meshes to array and get our spline meshes. Add it with the return value. For our return value, call set start and add. Get our spline. Then get location at spline point. Copy get location at spline point 4 times. Connect our spline to target and set the index to point index. Add index with 1 and connect it to point index. Then connect the return value to start post. Connect return value to start tangent. The third one connect to add post. And the last one connect to add tangent. For loop, when it complete, create a delay and get world data second. Connect it to duration. Before we predict the project car path, we get our spline. Then clear spline points. Then get spline meshes array. Call destroy component and connect our spline mesh to the target. Then we clear the array. Connect it to the predict projectile path and connect it to true. Select it and collapse nodes. Name it clear spline. Then get arrow curve. Create a branch. And if it's true, we predict the projectile path. And if it falls, we stop it. Go to our delay and connect it to clear spline. When we call the arrow curve project, we create the loop that we predict the path. When the arrow curve is full, we stop the loop. Go to pull string function, and if the string is tightened is true, we call arrow curve project event and set it to true. And if it's false, we call arrow curve project event and set it to false. Sorry for the mistake. For follow camera, we get world rotation, not world location. Roll, connect it to roll, and pitch, add it with 5 and connect it to pitch. And for the material, go to material light transparent and click on use with spline meshes. Let's play test it. Now we can see the projectile part of the arrow. To shoot the arrow, create a new actor, name it Blueprint Arrow Fly. Open Arrow Fly Blueprint, add static mesh, choose Arrow Static Mesh. Add a box collision, move it to the tip of the arrow, set the box extent to the size that we need. Go to event graph, click on box, scroll down. On component begin overlap, click the add button. Overlap other actor not equal to save and create a branch. Add projectile moment. This projectile moment will move the arrow. Set the initial speed to 6000 and max speed to 6000. And get projectile moment. Call stop movement immediately. For projectile movement, set projectile gravity to 0. Then get other actor and attach actor to actor. Other actor use it as parent actor. Location rule set it to keyword. Rotation rule set it to keyword. And scale rule set it to keyword. To spawn the arrow when we shoot, go to third person director blueprint, then add input action left mouse, call spawn actor from class, and go to predict projectile by trace channel, then copy the start position and the line velocity, paste it to the spawn actor, split struct pin of the transform. Use this location as the spawn transform location. And for the rotation, we make rotation from X vector. Use this rotation as spawn transform rotation. Choose arrow fly blueprint as the class. Then attach it with other node. Go to our scene and click on the static mesh. Search for collision and click on generate overlap event. Only the scene component that have generate overlap event that the arrow will stick with it. Right mouse and shoot it. Go near the arrow and we can shoot the arrow. We have to enhance the visibility of the arrow a little bit with the effect. Go to bow and arrow folder, then create new folder, name it FX. Right click, go to FX and create a Niagara system. Choose a new system and click next. Choose omnidirectional burst and click add. Click finish. Open and see it. Go to our arrow fly blueprint. Get our box world location. Call spawn system at location. Connect the world location to location. And for system template, select the new Niagara system that we just created. Go to third person director. Click on leg right and untick the debug draw. And click on leg left and tick the debug draw. Let's play test it. Now we can see the Niagara effect is bounded. This is the end of the bow and arrow tutorial, and if you have any question, please leave it in the comment section below, and please subscribe to my YouTube channel. It really means a lot to me. Thank you very much for watching, and see you in the future tutorial.